Welcome. We are going to talk about properties of exponents and scientific notation. First of all, let's review exponent notation. When you have b to the n, that's equal to b times itself n number of times. B is your base, n is your exponent. So I do kind of give a little bit extra here, and when we're talking about parts of the exponent. So there is a coefficient, then I have my base, and then I have my exponent. Let's look at these examples here. It says identify the base and the exponent. In this case, a coefficient 2. So what's in front of the 3 that's not written there? 1. So we're going to go ahead and say our coefficient is 1. Our base of our exponent is 3, and then our exponent is 2. So same thing for the next one. I see that I have x to the 6th. Well, I know that x is my base, so what's in front that's not written there? A 1. So 1 is the coefficient, my base is x, and my exponent is 6. Looking at the last example here, my coefficient is 3, my base is x, and my exponent is 6. So writing that out, that actually looks like 3 times x times x times x times x times x times x. The only thing that's being raised to that 6th power is the x. Let's look at this example here where we're simplifying. Looking at -3 squared, my base of my squared is the whole thing, which is -3. So you're actually looking at -3 times -3. That's when I get +9. Now the next example, I have -3 squared. My base is only 3. So written out, this looks like -3 times 3. That's why my answer here is -9. My base is 3, and that's what's being squared. Your calculator understands this also. So let's look at this example. All right, so I'm going to go ahead and put in my parentheses -3, close my parentheses, and square it. So right there it says my answer is 9. Now, if I just do -3 squared, my answer is -9. So half the battle when you're doing questions is plugging them into your calculator correctly, because your calculator does know order of operations. All right, so now with our exponents, we have some rules to our exponents, and they're really shortcuts for us. They're not necessarily rules, they're basically shortcuts. So the first one is our product rule. When you're multiplying like bases, the base stays the same and you add the exponents. Let's look at this first example. X to the 14th times x to the 2nd, they're both x's, so the x's stay the same, and you have 14 plus 2, so I get x is then equal to 16. Same thing with the next example. I have z and z. I'm adding my exponents. So when I add my exponents, I have -2 plus 10. My base stays the same, z, and I get 8. Looking at c. All right, so I'm looking for multiplying like bases. The base stays the same. Well, this can be changed around here. I have 4 times m times 6 times m. So really, when I'm looking at this, all of this is multiplication. So I have 4 times 6 times m times m. Well, I have m to the first times m to the first, so that's why I'm adding my exponents. I get 24m squared. Looking at example D, it's all multiplication. All of this is multiplication. So I'm going to go ahead and say 5 times -3 times x to the third times x times y squared times y to the 7th. So now I have -15 x to the third times x to the first, so I get x to the fourth, and y to the second times y to the 7th, I get y to the 9th. Now, a question that a lot of times does trip up students is when I have numbers instead. So let's say I have something like 2 to the 5th times 2 to the 10th. Remember that your base stays the same. So my base is still 2, and I add my exponent, which is 15. So I just kind of wanted to throw that extra little example in there. Power rule for exponents. All right, your power rule for exponents is, notice that I have parentheses here, and I have an exponent raised to another exponent. So a power raised to a power of a base, the base stays the same again. This time you multiply the exponents. So my base is going to stay the same here. I get x. Then I have a power to another power, so I'm going to multiply and get 12. My next example, z to the -3 to the 5th power. If I were writing this out, it would look like z to the -3 times 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 z to the -3. Then I'm multiplying like bases and I add my exponents. So when we say rules for exponents, it's not necessarily rules, it's shortcuts. So I really have z to the -15. All right, let's look at our next rule, power of a product. Now I have more than one thing going on in my parentheses, meaning that it's either multiplication or division. In this case, it's multiplication because it's power of a product. So I've got multiplication. Well, since I have multiplication, I would have 2 times x to the 6th 4 times. So if I write that out, 2x to the 6th times 2x to the 6th times 2x to the 6th times 2x to the 6th. So writing that out 4 times, how many times do I see my 2? Well, I see it's multiplying times itself 4 times. So that's 2 to the 4th times, and then I have x to the 6th, x to the 6th, x to the 6th, and x to the 6th, which is going to be x to the 24th. So I can look at this and I say, in my parentheses, make sure that you have all of your exponents written, okay? So every variable or number's exponent is multiplied by the exponent on the outside, not the number, but the exponent. So now I do have 2 to the 4th. If you're not sure, you can plug it into your calculator, 2 raised to the 4th, and I get 16 because it's 2 times 2. 4 times 2 is 8, times 2 is 16. So here I get 16 x to the 24th. My next example, I have -2b to the 3rd. This is when I am going to go ahead this time and say, well, my -2, that negative is with that 2. So I'm going to write a 1 there. And then I have b to the 1st also. So that I actually have -2 to the 3rd times b to the 3rd. Because what did I do there? I took my 3, that exponent on the outside, and multiplied each exponent on the inside, which was my exponents were not written there, they were 1. So now I have -8b to the third. Looking at my example C, multiplying, do I have an exponent on the outside of my parentheses? Yes. Multiplication is happening inside my parentheses. So therefore, every exponent on the inside of my parentheses gets multiplied by the exponent on the outside of the parentheses. X to the 35th times y to the 14th. When you see power of a quotient, it's really the same thing that we were just doing. It's just that it's division. Every exponent on the inside of the parentheses gets multiplied by the exponent on the outside of the parentheses. So looking at this example here, I have m to the first divided by n to the second. Multiplying my exponents, I have m to the fourth divided by n to the eighth. That's it. Looking at my example B, every exponent on the inside of the parentheses gets multiplied by the exponent on the outside of the parentheses. If you don't see an exponent, write a 1. So 3 to the first, a to the second, 2 to the first, b to the fifth. Now every value has an exponent. So now every exponent gets multiplied by the exponent on the outside of the parentheses. 3 to the third, a to the sixth, divided by 2 to the third, times b to the 15th. 15, there we go. Now you're going to simplify. 3 to the third, 3 times 3 is 9, times 3 is 27. So I have 27, a to the sixth, divided by 8, b to the 15th. My quotient rule. So here I don't have any parentheses. There's no exponent on the outside. Here my quotient rule says, like bases stay the same, the denominator is subtracted from the numerator's exponent. So I know that I look at this and I say, where's my highest exponent of y? Well, it's in the numerator. What are you actually doing here? You're actually dividing out. If I were to write this first one out, which is a lot, so here I'm writing it out. Then I divide it out. How many y's are left in my numerator? There's 8 because my highest exponent of y was in my numerator. So I have y to the 8th. Now looking at example B, where's my highest exponent of a? On the top. I'm dividing out the a, so how many a's are left? 5, because it's really 6 minus 1. So with C, I have x squared divided by x squared. Well, I have 2 minus 2, which is 0. But really, if you're looking at this, I have x squared divided by x squared, which is 1, which leads us right into 0 exponent. This right here is x to the 2 minus 2, which is x to the 0, which is 1. Another way of looking at this is the example that's right in front of A. Another way of looking at this is example A. Let's look, I have x to the 0. Well, that really means that I see no X's. But what's in front that's not written there? A 1. So really, I just have 1 here. Same thing with B. I have 5 to the 0, which means I actually see no 5s, but what's in front that's not written there? Yeah, 1. Anything to the 0 power, it doesn't matter what's in front of, what's inside my parentheses there, there's a 1 out in front. 1. Now looking at D, what's being raised to the 0 power? Yeah, just 3. So here I have 4x plus 1. My 3 to the 0 is 1. Now looking at E, what's the base of my 0 exponent? 5. What's my coefficient? -1. Looking at example F, I have -5 raised to the 0 power. This time, -5 is my base. So if I cross that out, what's in front that's not written there? A 1. Negative exponents. Negative exponents, negative exponent means the reciprocal. You flip the fraction. Well, if you're looking at example A, you say, I don't have a fraction there. Now I have a fraction. Just put a 1 underneath it. Now it's a fraction. So it takes its base and jumps the line. So I have 1 divided by x to the n. That's kind of the way I see it. Same thing, reciprocal means the fraction flips. So B is already a fraction. So what is it going to do? It's going to flip. The sign that's in front isn't changing. The only sign that changes is the exponent. So I have y to the 3rd divided by 1, which is just going to be y to the 3rd. So with C, where's my highest exponent of n? It's in the denominator. So I say 1 divided by n to the 2nd, because then I just divide them out. Now, if you were to follow the rules, you can follow the rules, and it would actually say n to the 6 minus 8, which would then be n to the -2. Well, you don't leave exponents negative. You have to write them as positive. So since I have n to the -2, that fraction has to flip, and I get 1 over n squared. For me, when I'm simplifying that though, I just look at where's my highest exponent of n. It's in the denominator, so n stays in the denominator, and I don't make anything negative. All right, so looking at D, the first thing I see here is I have a negative exponent. So I would rewrite this as p to the 6th divided by p to the 9th. Because that negative, that 9 is negative, so it needs to go in the denominator. Now I look, where's my highest exponent of p? It's in the denominator. Since there's nothing else in the question, there's a 1 that's left in the numerator. And how many p's are left in the denominator when I divide them out? 3. So there are basically my rules of exponents, which are really shortcuts. Simplifying exponents. Now you have to put that all together. And now you're just going to be simplifying. Are you going to use every single step every single time? No. So I will tell you that these are the steps that I take. They might be a little different than the steps that you take, but these are the steps I take every single time, and I'll have no more than 4 steps. So first thing I do is I'm going to get rid of my parentheses. Then I make all my exponents positive, simplify the numerators and denominators separately, look for like bases in the numerator and denominator. reduce that, and then you never leave an exponent negative. First example, my example A. So I would get rid of my parentheses first. In other words, I'm looking for, do I have an exponent on the outside of my parentheses? Nope, no exponent on the outside of the parentheses. So what am I doing here? I'm just multiplying. So I know that I have 4 times n to the third times -3 times n to the fifth divided by n to the second. Do I have any negative exponents? All right, so simplify my numerator. So simplifying my numerator, I have -12 n to the 8th divided by n to the second. There was nothing to reduce or nothing to simplify in my denominator. And then it says, look for like bases in the numerator and the denominator. So do I have like bases here? Yeah. Where's my highest exponent of n? Yeah, it's in the numerator. So n stays in the numerator and I'm dividing out 2 of them. So how many are left? 6. So I have -12 n to the 6th for that example. All right, let's look at B. Do I have any parentheses? No. Do I have any negative exponents? No. It says simplify the numerator. There's nothing to simplify there. Simplify the denominator, nothing to simplify there. Now I'm going to look for common bases, like bases in the numerator and the denominator. Well, first of all, I have my numbers, right? So I know 8 goes into itself once, goes into 16 2 times. I know I'm going to have a fraction where my denominator is going to have a 2 in it. I'm not going to worry about writing that 1 yet because I'm going to see if there's anything else that's left in that numerator. Where's my highest exponent of x? On the top. So x then stays on the top. How many are left? 7. Where's my highest exponent of y? On the top. So y stays on the top. Dividing out my y's, how many are left? 1. There's my answer. C. Get rid of my parentheses first. Do I have any exponents on the outside of my parentheses? Yes, that second parentheses. So my first parentheses, I just have 3 times y to the -8 times 5 to the third times y to the 6th. The only thing that was being multiplied by 3 are the exponents. So now, do I have any negative exponents? Yes. Can I go ahead and multiply that 3 times 5 to the third? Absolutely. So 3, I'm going to go ahead and do it right here. 3 times 5 to the third. So I have 375. And then I have y to the 6th divided by y to the 8th. Now I have nothing left, nothing left to simplify in the numerator, nothing left to simplify in the denominator. Where's my highest exponent of y? In the denominator. So y stays in the denominator. So then simplifying here, I have 375 divided by y. When I divide them out, I'm left with 2. D, do I have any parentheses here? Nope, no parentheses. Do I have any negative exponents? Yes. So this negative exponent comes down the a to the 6th stays where it is. What's left in the numerator is 1. So I have a to the 6th times a to the 4th. Simplifying my numerator and then my denominator, I have 1 divided by a to the 10th. There's nothing else to do. There's my answer. Looking at E, do I have parentheses here? Yes, I have parentheses. I have to get rid of my parentheses first. Every exponent on the inside of the parentheses gets multiplied by the exponent on the outside of the parentheses. So I'd have 4 to the 2nd divided by n to the 10th. Simplifying 4 to the 2nd, I get 16 divided by n to the 10th. There's my answer. Example F. Do I have parentheses here? Yeah, I have parentheses here. So now I have -4 to the 2nd power times x to the 10th times y to the 6th. Every exponent on the inside of the parentheses. So remember, there's a 1 that's there. You can go ahead and group that negative with that 4, because that's my coefficient of what's in my parentheses. So -4 squared is going to be 16, x to the 10th, y to the 6th. G, do I have an exponent on the outside of the parentheses? Yes. Every exponent on the inside of the parentheses gets multiplied by the exponent on the outside of the parentheses. 3 to the 4th, m to the 20th, z to the -28th, divided by 5 to the 2nd, m to the 2nd, and z to the 6th. Do I have any negative exponents? Yep. My z comes down. I can go ahead and start to simplify. 3 to the 4th is 81. M to the 20th divided by 25. M squared. Z to the 6th times z to the 28th. Now I'm simplifying. I'm looking for common bases and what I need to do with those common bases. My 81 and my 25, nothing's going to happen with those. So I have 81 in my numerator, 25 in my denominator. Where's my highest exponent of m? On the top. So then I have m. When I divide them out, I'm left with 18 on the in the numerator. And then z to the 6th times z to the 28th is in the denominator. So I add those exponents together because they're both positive. Once I move that one down, they're both positive. So now I have z to the 34th. Example H. First thing I look for is parentheses. Do I have any parentheses here? Nope, no parentheses. Do I have any negative exponents? Yes. So these two are actually going to switch places. So I have 4m to the 11th divided by m squared. Now I look at where's my highest exponent of m on the top. So m stays on the top. I don't have to write a 1 in the denominator. I have to write a 1 in the numerator. I don't have to write a 1 in the denominator. I do have to write a 1 when there's 1 that's left in the numerator, but not in the denominator. So here I have 4m to the 9th. Example I, I don't have any parentheses. I don't have any negative exponents. I have y to the 0 power, which means I don't see any y's. So since I don't see any y's, the only thing that's left is the coefficient, which is negative 10. Looking at J, I don't have any parentheses here, so there's no multiplying any exponents. I do have some negative exponents. So that's going to be the first thing I'm going to take care of. I'm going to leave this 4 and 20 where it is. A to the 2nd is positive. B to the negative 9th, that's going to go down. And then I have C in the numerator. Then in the denominator, I have A. I know that B to the 9th came down. That B to the 3rd is going to go up. And that C squared is going to go up. So let's just talk about what I did right here. I took A squared, stayed there. B to the negative 9, it went down. Okay, so it went to the denominator because that's the reciprocal, is in the denominator. C stayed where it was because it's positive. 20 stayed where it was. A stayed where it is. This B to the negative 3 went up, and this C to the negative 2 went up. Now I'm going to simplify my numerator. Can I go ahead and reduce the fraction, my coefficients? Absolutely. 1 and then 5. So I have A squared in the numerator, B to the 3rd, and then C to the 3rd. Divided by 5, A, B to the 9th. So I simplified here. A was just A squared. C times C squared is going to be C to the 3rd, and then I have that B to the 3rd. Now I'm going to look. Do I have any like bases between my numerator and my denominator? Yeah, absolutely. That 5 is going to stay in the denominator. Where's my highest exponent of A? On the top. How many are left? 1. Where's my highest exponent of B? On the bottom. How many are left when I divide out? 6. And then C, there are no like bases, so there's just C to the 3rd in the numerator. Looking at K, threw this one in here because it's not a product. It is not a quotient. So therefore, you cannot distribute that squared. When you're simplifying this, that's when I have to do, it's kind of written backwards for me, but that's all right. I have to write it as 8 plus x times 8 plus x, which means, what do I have to do? Distribute. It's not the same thing as up here. This right here is not the same thing as two x to the 6 times 2x to the 6 times 2. That's all multiplication. This is all multiplication. So then I can say, well, I have 2 times 2 times 2 times 2, which is 2 to the 4th. You cannot distribute a square if you have addition or subtraction. So here I would get 64 plus 8x plus 8x plus x squared. Then combining my like terms and writing it in standard form, I would have x squared plus 16x plus 64. Looking at my last example, do I have an exponent on the outside of the parentheses? Yes. Then every exponent on the inside of the parentheses gets multiplied by the exponent on the outside. 1, 1, 1, 1. So negative 8 to the 5th times x to the 15th times y to the 25th divided by 4 to the 5th times x to the 5th times y to the 5th. Could you reduce your fraction first? Yes. Will it change your answer? No, it's not going to change your answer. So here, I'm going to go ahead and simplify. This does make my numbers larger in this case. That's not always the case, but I'm going to go ahead and say negative 8 raised to the 5th. And then I'm going to go ahead and say, I'll just write that. So negative 3, 2, 7, 6, 8. So negative 32,768. And then I have, where's my highest exponent of x? Yeah, on the top. Can I go ahead and simplify that? Absolutely. So I would have x to the 10th and then y to the 20th divided by 4 to the 5th. So 4, oops, here, 4 to the 5th. So I get 1,024. And now I'm going to divide negative 32,768 divided by 1,024. So I get negative 32. So my answer, negative 32, x to the 10th, y to the 20th. So this one example that I just did, that last example, that's the one time that it's a lot more work to not reduce your fraction first. But just remember, these two questions right here, G and I, just remember that G and L right here are very different questions, because this one I had a 5 on the outside of the parentheses, which was the whole thing. Whereas this one, I had different exponents in the numerator than the denominator. But probably with L, if I would have reduced my fraction first, it would have been a lot easier. Just saying. A lot of times I don't think about that though. I don't look at that, I just follow the same steps. The last topic in this particular section is scientific notation. So parts of scientific notation is you have this constant value that's right here, which we call A. And A is greater than or equal to 1, but less than 10. So can you have a negative out in front? You could have a negative out in front, but that's not what we're talking about. Okay, we're talking about the A part has to be between 1 and 10. It has to be less than 10, but greater than or equal to 1. And then times 10 to some exponent. Well, that's the number of zeros that you have, and it's the direction that you have. Is it a positive or a negative? So it says, write the following numbers in scientific notation. You have to be careful when you're writing these. So first thing I'm going to look at here is I need my number. So I'm going to look at the first two places on this particular number. And I need those two values. I need it to be between 1 and 10. So I'm going to go ahead and say 8.6 times 10. So here's where I'm putting the decimal and I have to count how many places I moved it. 1, 2, 3, 4, 5, 6, 7, 8. And it is a positive 8. It's a positive 8 because that's the way I move the decimal. Looking at my example number 2. First thing I'm going to do is I'm going to find my numbers. So here are my numbers, which are going to be my first two places that are going to be represent my A. And I need my number to be between 1 and 10. So I have 4.23 times 10. Now I'm going to place my decimal where it should be and then count how many places to my decimal. 1, 2, 3, 4, 5 in the negative direction. So when my number has a lot of zeros in front, my exponent is negative. When my number has a lot of zeros after is when my exponent is positive. Looking at example 3. So here's where it's already written in scientific notation. I need to write it in standard form. So remember, it's negative, so I'm moving it in the negative direction. 1, 2, 3, 4. So 0 point, fill those in with zeros. 1, 2, 3. 1, 2, 3, 3, 2, 5. Looking at number 4, my decimal is here. I'm moving my decimal 6 places. So 1, 2, 3, 4, 5, 6. So 5, 1, 0, 0, 0, 0, 0. Looking at number 5. Number 5, it's negative. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Number 6, it doesn't matter that my number is negative. That just means my number is going to stay negative. So 1, 2, 3, 4, 5. So negative 2, 6, 3, 1, 2, 3. So I have negative 263,000 for number 6. Number 7 says which number is larger? Well, this one, right? I'm going to move my decimal place 8 places, and this one I'm moving my decimal places 12 places, so positive 12. So therefore, which number is going to be bigger? Yeah. Now, which number is larger when you have a negative exponent? Well, when you have negative exponent, you want it closer to 0. So which one's going to be closer to 0? The one with the least amount of zeros in front. When you're dealing with scientific notation and you're wanting to multiply or divide, can you use your rules of exponents? Absolutely. So everything that's happening right here in example 9 is multiplication. So I have 5.2 times 10 to the 7th times 3.1 times 10 to the negative 2. Well, I'm going to go ahead and multiply my two numbers together that I have right there. So I have 5.2 times 3.1, and I get 16.2, and then, or excuse me, 16.12, 16.12. Okay, there we go. Got it right. And then I have times 10. Well, I'm multiplying my 10 to the 7th times 10 to the negative 2. So I add the exponents and I get 5. Now I have to look, is my number in scientific notation? It's actually not in scientific notation because what has to be true about my A? Well, my A has to be between 1 and 10. It's not. So I have to move my decimal here, right? So I know my number is going to be 1.612 times 10 to the, right? Well, I'm moving it to that, well, I want it to go, when you're looking at it, I'm moving it one decimal place, but I need that extra 10 on there, so it's 10 to the 6th. So I want it here, and that here's where my original was. So same thing with number 10. I have division that's going on here. So the first thing I'm going to do is I'm going to take 9 and divide it by 1.2. So I get 7.5 times 10. Then I have 8, 10 to the 8th divided by 10 to the 3rd. My base stays the same and I subtract. So I get 5. Is this in scientific notation? Yes, it's in scientific notation. So therefore I just leave it just like that. Now, if these questions right here were wanting them in standard form, then I would of course have to write them out in standard form. It just depends on how the question is asked. Good luck on your homework. Have a great day.